Hi everyone, this is Mrs. GA, and today we're going to learn how to shift all of the different conics that we've been learning how to graph. Okay, so here is a general overview of the different types of conic sections that you should be familiar with. And I like this visual because it really helps you to understand where they come from and why they're called conic sections. So if you take two inverted cones like you see in all of the images, and then you take a plane and intersect the cones in different ways, you can get four different types of shapes. So one is you can get a circle, and that's if the plane is exactly parallel to the base of the cones. You can get an ellipse, so imagine the plane is at a different angle. It only intersects one of your cones, but you can see it makes that oval shape of an ellipse. And then if it is even more at an angle, so it doesn't actually cut through the sides of your cone, you get that parabola shape. So right here. And then if it intersects both cones like that, you get that hyperbolic shape. So those are the four types of conic sections that you should know how to graph and interpret the equations. So here's a really big overview of the different types of conic sections, what their equations are, and some important information. So this lesson is definitely intended for people that have already watched the previous one, so you should already be very familiar with the parabolas, ellipses, and the hyperbolas. Circles, I just threw that in as a little extra review. So if you're not already familiar with these, then definitely go back and rewatch those videos to refresh. The only thing that's different about these forms of the equation is now you'll notice that they all have vertical and horizontal shifts. So there's something being added or subtracted to x and y. So this is the general form of an equation of a circle. Hopefully this looks familiar. The center is at hk and the radius is r. So for our vertical parabola, so notice instead of just being x squared is x minus h squared. The 4p is still here, and now it's times y minus k. So the only thing that's different here is that it's been shifted. So you shift it according to where the vertex is, which will be at hk. And then here's a quick reminder that p is the distance from the vertex to the focus, or from the vertex to the directrix. And if p is positive, it opens up or to the right. If p is negative, it opens down or to the left. And here's the same thing, but for the horizontal parabola. So remember, it's horizontal if the y term is being squared. So notice that h is still grouped with x. H is a horizontal movement, so it's always grouped with x. And k is still grouped with y. Okay, for your two ellipse equations, so notice it's exactly the same as the ones you learned, except now it says x minus h and y minus k. So there is that horizontal and vertical shift. So just a quick reminder, for your ellipses, you determine if it's horizontal or vertical by where your larger denominator is. So if the larger denominator, which is a squared, is under your x term, it's horizontal. If your larger denominator is under your y term, it's going to be vertical. And then here our center is always going to be at hk, and a is the distance from the center to the vertices, whether that's horizontal or vertical. B is the distance from the center to the co-vertices, and then C is the distance from the center to the foci. And this is the equation of how you find that C value. Okay, and the last two are the hyperbolas. So remember, it kind of looks like an ellipse equation, except it's a difference instead of a sum. It's going to be a horizontal hyperbola if your x term comes first. So remember, for these, notice a squared always comes first. So if your x term comes first, it's horizontal. If your y term comes first, it's vertical. So you'll see here again we have the shifts that help us find the center, which is going to be at hk. A, remember, is the distance from the center to the vertices. Here it's going to be horizontal, here it's going to be vertical. B, we use as the distance from the center to the other side of that slope box. Remember, we create that little slope box that helps us draw our asymptote, so I'll just call it the slope box. And C is the distance from the center to the foci, which again, if it's vertical, it's going to be up and down. If it's horizontal, it's going to be side to side. And here's the equation for the c, to find the c value for the hyperbola. So notice again, look at how similar the ellipse and the hyperbola equations are. Make sure you can keep them separate. So again, this is a really big overview. If any of this doesn't seem familiar, make sure you go back and watch the video for that particular conic. Although circle, I didn't make a new one for pre-calculus. This should be something that you know from previous courses. Okay, so as we work through these few examples together, our job is going to be to identify the type of conic it is and then sketch a graph. So sometimes it will already be in standard form and sometimes we'll have to rewrite it in standard form. Okay, so just based on the form, both x and y are squared and it's a sum. We know that this is going to be an ellipse. And if I'm going to be even more specific, since the denominator is larger under your y term, this is going to be a vertical ellipse. Okay, so let's start with kind of the most important starting point for graphing at least. We'll start with the center. So remember our center is always at HK. And remember, since it says x minus h, y minus k, it implies that it's going to be opposite value of what you see here. So the center is actually at -1, 2. So we can start by plotting -1, 2 right here. Now we're going to look at it and identify our a value. So remember, a squared is always the larger denominator. So I can see here that a is 3 since a squared is 9. Now since it's vertical, that means from the center, I'm going to go up 3 and down 3 to find my vertices. So I have one vertex here and one vertex here. Now I'm going to find my b value. So b squared is 4. So that means that b is 2. And again, this will be a horizontal distance. First of all, I know that because it's underneath the x term. And second of all, the b value tells you your co-vertices, which are on your minor axis. So I'm going to go to the right 2, place a point, and to the left 2 and place a point. So here we do have the general shape of our ellipse. So it looks like this. And we are going to want to include our foci as well. So we're going to use our little formula, c squared equals a squared minus b squared. So in this case, c is the square root of 5. So we're going to start again. This always goes from the center. And we're going to go, it's going to be up and down because it's a vertical ellipse. Square root of 5 is just a little bit more than 2. So I go a little bit more than 2 up, so right here, and a little bit more than 2 down. And if you were trying to name these foci, you would start with the center point, right? So the center point is at -1, 2, and then you're essentially adding square root of 5 to your y value and subtracting square root of 5 from the y value. So it's -1, 2 plus or minus root 5. So that's how you could name the coordinates of the foci from there. But again, if you have your graph, it makes it a lot easier to visualize where your coordinates would be. Okay, let's try this next example together. So here you can see that only x is being squared, and so from this we can probably infer that this is going to be a vertical parabola. However, it is certainly not in that standard form that we saw before. So remember, we would like it to look like this. X minus h squared equals 4p times y minus k. So a couple things we're going to need to do. We are going to need to complete the square here so we can create a binomial squared. So let's start by doing that. So we have x squared minus 4x plus some magic number. So remember, the way you find that magic number is you take your b value, you cut it in half, and you square it. So it is going to be 4. Now just remember, you do need to add 4 to both sides. That's the step that people usually forget. So plus 4 here. So this gives us x minus 2 squared equals 8y minus 24. So we're almost there, but notice that we do need to factor out any coefficient of y, so it's just 1y inside your parentheses. So here we can factor out an 8, and we get 8 times y minus 3. And now this is in our standard form. Okay, so to graph this, we can start with the vertex, which remember is going to be hk. So in this case, we can see that it's going to be positive 2, positive 3. It's going to be right here. And then for us to find our focus and our directrix, we need to know our p-value. So notice that this number right here should be equal to 4p. So we say 4p equals 8. So our p-value is 2. So remember, the p-value is the distance from the vertex to the focus, or the vertex to the directrix. Now, since this is a positive p-value, we are going to have a positive parabola, so it's going to be upward facing. So there's just a really rough sketch. And then again, from our vertex, we go 2 units exactly up. So we go to right here. And then we go back from our vertex. If you go 2 units down, we're going to draw in a horizontal line for our directrix. So we want to make sure we include both the focus and the directrix. And then just by looking at your graph that you just made, you should be able to name the coordinates, the coordinate of your focus and the equation of your directrix. All right, let's try this next example together. So here, this is clearly not in standard form yet, but I do notice that both x and y are being squared, and I notice that this is a positive term and then this is a negative term. So this implies to me that this is going to be a horizontal hyperbola. So again, I knew that it was horizontal because I see that the x squared is the first term that's positive and the y squared is the negative one. And again, we know it's a hyperbola because there's that difference instead of the sum that you see with an ellipse. So if you remember what the horizontal hyperbola looks like for the standard form, it's going to be x minus a squared over a squared minus y minus k squared over b squared equals 1. So we are going to need to start by completing the square for both x and y. So they're already grouped next to each other, which is nice. However, one thing you do need to note is that you cannot complete the square if there is a coefficient other than 1 for your term that's being squared. So before we do anything, we do need to factor out 9 and negative 16. So let's start by factoring out the 9 from our x terms. So that leaves us with x squared minus 8x plus blank. I'm going to leave a blank for a number that completes our square. And then here we're going to factor out negative 16 times y squared plus 2y. Then I'm going to leave a space to complete our square here. And then here we still have equals 16. So remember, to complete the square, we cut this in half and square it. So it looks like we're adding 16, but really we're adding 16 inside of a trinomial that is being multiplied by 9. So we are actually adding 9 times 16, which is 144. So be really careful that you understand what we are actually adding to each side of your equation. And then here again, cut this in half and square it, so our magic term is 1. But again, we're not actually adding 1, we're actually subtracting 16 from each side. Okay, let's see what we have now. So this becomes 9 times x minus 4 squared, if you factor it, minus 16 times y plus 1 squared. equals 144. So we're a little bit closer, at least we have our binomial squared, but we do need to have our equation set equal to 1. So now we're going to divide both sides by 144, and that gives us x minus 4 squared over 16 minus y plus 1 squared over 9 equals 1. So now we have an equation in standard form, and we can see that yes, in fact, it is a horizontal hyperbola, and that means that we're ready to start graphing. Okay, so let's start by identifying our center. So our center again is going to be HK. So our center is at positive 4, negative 1. So we can start by plotting that point. So now that we know that it is a horizontal hyperbola, we know that our A value will tell us where our vertices are, and they're going to be to the right and left of our center. So here I can see that A squared is 16, which means that A equals 4. So from the center, I'm going to go 4 units to the right, and I'm going to put a vertex, I'll do it in red, and then 4 units to the left. So those are my 2 vertices. We can also take a moment to find our foci. So we do need that C value. So we're going to use the formula C squared equals A squared plus B squared. So remember, the formula is a little bit different than an ellipse. So here we get C equals 5. So this tells us to start at the center and then again go to the right 5 and to the left 5 to place our foci. So I'll place those in green. And then for a hyperbola, it's important for us to know the general shape of each part of your curve, and for that we do need our asymptotes. So remember, we can then use our B value to help us make that slope box to draw our asymptotes. So our B squared term is 9, which means that B is 3. So from the center, we go up 3, and there's a little guideline, and then down 3, and then we connect that with where our vertices are, and then that gives us our slope box. So our asymptotes are going to go right through the corners of that slope box, just like that. So we could see from this that the slope of this line is 1, 2, 3 over 1, 2, 3, 4. So we can use this to guide when we actually trace our curves. So our curves are going to look something like this. And there you go. So again, we do have to put in a little bit of legwork here to actually put our equation into standard form. But once we know where our center is, the rest is really just what we've been doing in previous lessons. Okay, so at this time, I'm going to ask you to pause the video and see if you can give this example a try. So write it in standard form, identify it, and then sketch a graph. Okay, so let's go ahead and check. So the first thing to check for is that you have your equation in that standard form, and it should be x minus 2 squared equals 36 times y minus 3. So this is a vertical parabola. The vertex is 2, 3. So right here, the p value is 9. So from the center, if you go, or from the vertex, if you go up 9, you find your focus, which went a little bit off my graph, but it's here at 212. And then back from the vertex, if you go down 9, you'll find where your directrix is at y equals negative 6. Okay, so again, please pause the video and give this problem a try. Okay, let's go ahead and check your answers. So the first thing to check is that you're able to get this equation. So from here you can see that this is a horizontal hyperbola. We know that it's a hyperbola because there's a difference between x squared and y squared, and we know it's horizontal because the x term is the first term. So our center is going to be at 4, -1. I see a squared is 16, so a is 4. So if you start at your center, you go to the right 4 and left 4 to get your 2 vertices. Your b squared term is 4, so b is 2. So again, if you go back to the center and you go up 2 and down 2, you can create this little box that you use to help you with the slope of your asymptotes. So here you can see that I drew in the asymptotes. And that helps you to guide the shape of your hyperbola. And then we also need our foci, which means we need to find our c value using this formula. So we get c equals 2√5. So remember, the foci, you start at your center, which is 4, -1, and then we're going to go to the right and the left 2√5. Now, since we're moving to the right or left, we're going to add and subtract that from our x value. So our foci are located at 4 plus or minus 2√5, -1. Again, the 4, -1 is just from the center, and it's added to the x because we're moving left and right. Now, if you wanted to make the equations of your asymptotes, just be careful. You can use the slope box to find your slope. So you can see its rise over run is 2/4, which is 1/2. But remember, you need to write it in slope-intercept form. So if you carry your graph on, if you have a nice accurate graph, you can see that my y-intercept for the positive slope is -3. And then for the asymptote with the negative slope, you can see that the y-intercept is +1. So that's how I got the equations for my asymptotes. Okay, here's the last one I'm going to have you try on your own. Go ahead and pause the video again and see if you can identify it and sketch it. All right, go ahead and check. So you can see this is already in standard form, and it is a vertical ellipse. Ellipse because it's a sum and both x and y are squared, and it's vertical because the larger denominator is underneath the y. So our center is at 5, 3. Since a squared is 36, a is 6. So from the center, I go up 6 and down 6 to get my vertices. B squared is 16, so B is 4. So again, from the center, I go to the right 4 and to left 4 to get my co-vertices. And for my foci, I need that c value. Be careful that you're using the right formula. We get c equals 2√5. So from the center, again, you start at your center point, and since it's a vertical, we're actually going to move up and down, which means we should add or subtract this from our y value. So the coordinates would be at 5 and then 3 plus or minus 2√5. Again, all we're doing is adding and subtracting 2√5 from the y value because we want to move up and down 2√5. Okay, so we do have one last example. This is kind of a special case, and it's what's called a degenerate conic. So let's approach this like we would any other problem. We look at this and we say, well, I have x squared and y squared, but one's positive, one's negative. What this looks like is probably going to be a horizontal hyperbola. So we're going to try to put it into standard form. So again, we will group our x terms together like this, and then we'll group our y terms together so we can start that completing the square process. So remember, here we actually need to factor out the 9. And then here we're going to be adding 1 inside the parentheses. We'll deal with what we're actually adding in just a moment. And then here we're going to need to factor out the -1, leaving us with y squared minus 6y. And then if you cut this in half and square it, we get plus 9 equals 0. Now be careful here because here we're actually adding 9. And here we're actually subtracting 9. So we still end up with 0 on the right. But it's really important that you check to make sure that you're doing the same thing to both sides of your equation. So this leaves us with 9 times x plus 1 squared minus y minus 3 squared equals 0. So here you can probably start to tell that things aren't quite going right, but we definitely don't want to have a number on the top. So let's say we divide both sides by 9. So we divide every single term by 9. We can do one step further, and this would be y minus 3 squared over 9. But this side would still say equals 0. So again, this almost looks like a hyperbola, but we know that this should always be equal to 1. For our standard term, it should never equal 0. So whenever you have something that looks like it could be in the form of a conic, so both x and y were squared, it's a sum and a difference. However, it doesn't quite turn out to be a conic. We would call this a degenerate conic, and more specifically in this case, we would call this a degenerate hyperbola. So again, this is kind of a unique case where actually if you set the two parts equal to each other, it ends up being just two lines that are equal to each other. So if you ever come across something like this where it's not quite right, again, we call it a degenerate conic, and it's more of a special case scenario. Okay, so that is all for today's video. Thank you so much for watching.